Number 11 says to match the series with its sum, and it gives you 3 different series and 3 corresponding sums on either side. So when I look at each one of those sums, the first one that kind of stands out to me is the second one. I have n equals 0 to infinity of 8 to the n over 4 to the n factorial. So the one thing that stands out to me is that I can actually combine these n terms. So remember, if I have terms to the same power, I can just go ahead and combine them. So I end up with n equals 0 to infinity of 8 over 4 to the n, which is just 2 to the n, over n factorial. Well, thinking back to my Maclaurin series, I do know a series that looks like that, because I remember that e to the x is equal to the summation n equals 0 to infinity of x to the n over n factorial. So this fits the exact formula. The only thing that's different is that x is just equal to 2. So therefore the sum of this is just equal to its function evaluated at 2. So it would be e squared. So that means that for this first one, or for that number, that Roman numeral 2, the answer would be a. So we have a little a up there. Okay? Now, the next one that stands out to me is number 3. So I'll just denote this as Roman numeral 2. Roman numeral 3 is the summation n equals 0 to infinity, negative 1 to the n plus 1, or to the n, never mind, over 2n plus 1. So at first glance, 2n plus 1 kind of looks like sine. But the only thing that's different is that sine is a factorial on the bottom. So this isn't sine of x. But there's another function that does look very similar to it, and it just had a 2n plus 1 on the bottom. I know that one as arctangent of x. So arctangent of x was pretty similar to it in general, but I have a negative 1 to the n, x to the 2n plus 1 divided by 2n plus 1. So there was no factorial on the bottom for arctangent of x. So this does fit the exact form. The only thing that's missing is that there isn't an x to the 2n plus 1. Well, what value would I have to plug in to get this to go away? Well, if I plugged in a 1, I could turn this into 1 to the 2n plus 1, which would just make the whole thing 1. So there's probably like a 1 to the 2n plus 1 right here, which means that the value I'm plugging into my function is equal to arctangent of 1. And if I think back to my graph of arctangent of 1, arctangent of 1 is equal to pi over 4, because pi over 4 is where tangent is equal to 1. So that would mean that looking at my answers, that would denote this as C. Now I could probably figure it out from here. I believe the answer in this case should be letter C, big letter C, which would insinuate that the only remaining one is natural log of 2. But how do I know that Roman numeral 1 is equal to natural log of 2? Well, if I look at the series, I have it from n equals 1 to infinity, negative 1 to the n plus 1 over n. Now again, I know that this does fit one that we have seen before. Just so happens though is that it's a little bit different because it's not actually centered at 0. It's centered at negative 1. It should be 1 plus x to the n plus 1. Or sorry, just to the n. X plus 1 to the n. So that tells me, sorry, this should just be x to the n. So that would just be x to the n. But it's equal to natural log of 1 plus x. So it is centered at 0, but that just comes from the fact that the natural log originally was centered around a different point. So if I have natural log of 1 plus x, it's equivalent to this series. And that just comes from the same definition of deriving all the terms out and actually figuring out what you get. So again, if I look here, there isn't an x to the n term in this series. But what that means is that if I just plug in x equals 1, I could get that to go away, but the whole series wouldn't be 0 because I would just be now multiplying by 1. So that means that I would just need to plug in an x value of 1 into here, which ends up getting me a sum of natural log of 2. So I was able to back out all the sums for the following series. So that means that my overall final answer is big C.
The Teaching Center, UF's Learning Resource Center.